All right, so today we're going to be going over functions in Python. So up to this point, we've learned a lot of various things, and we've been writing all of our code in individual files in like a scripting fashion, where we don't actually have functions building out throughout the code. And functions are a great way to store our code in a repeatable in like a section in a chunk of code that would be very repeatable, basically. So we'll see how we can do that through this lecture. So let's go ahead and get started. All right, so what is a function? A function can be thought of as a named and stored code block that runs only when it's called. Typically, this is a block of code that you'd otherwise have to repeat in your program multiple times. So say we didn't have a function for repeated code. What happens when you need to change a portion of that code block? You'd have to change it everywhere throughout the code, everywhere that the code block appears throughout your file. And functions help make it so that you only have to make a change to that code block in one place throughout your code. So it saves you a ton of time with having to go through your code and find everywhere that the code is repeated, and then make the change in all of those different places. So functions are defined using the def keyword, and we'll see some examples of that here in a moment. And functions can optionally accept inputs called parameters or arguments. And functions always return data to the caller, but sometimes the amount of data that's returned to the caller is vastly different. So sometimes it'll just be a none object, or sometimes it'll be some actual data, and we'll see examples of that as we go through the slides. And so we've actually already been using built-in functions throughout the course. So we're already familiar with calling functions here. We're really going to be diving into how you're going to define a function. So some of the functions that we've used so far throughout the course are the print function. The print function outputs whatever is entered as a parameter to that function. It outputs that to the console. The stir function, it converts whatever is passed to it as a parameter. It converts that to a string. And the int function converts whatever is passed as a parameter to it to an integer if the conversion is logical. Otherwise, it results in an error. So any function is always going to have a name and then these parentheses following it. The parentheses are very important when you're actually trying to invoke the function. If you try to refer to the function without the parentheses, you'll get some weird object that's kind of hard to recognize what's going on. So just keep in mind that whenever you call a function, it should always be followed with parentheses. And depending on the function, sometimes it has arguments passed to it, like the print function. Typically, you're going to put some string inside of that print function to output that to the console. Cool. So not seeing any questions in the chat, so we're going to keep moving along. But please, if you do have any questions, just throw them in the chat. I think that's been working really well so far. All right, so defining a function. So functions are declared using the def keyword, followed by the function's name, then parentheses, and a colon. The code that defines the function, or aka the function body, is indented underneath the function declaration, kind of like how we've seen with for loops and if statements. The body of that for loop or the body of that if statement is indented underneath the if or for loop. Same thing goes for a function. You want to make sure that you indent the body of the code that's going to be part of the function underneath the function declaration. And then parameters, also called arguments, if present, are defined within the parentheses of the function declaration. These parameters can then be used within the function definition. So it's basically like you're creating temporary variables that are scoped to within that function. So then you can refer to those scoped variables within the function, and then whenever somebody would pass something into that function in place of that parameter, it would be assigned the value of that parameter within the function body, and we'll see examples of that here in a moment. So down here, I'm defining a very simple function. So we start with the def keyword here, and then a space. And we have our function name. Remember, the function name shouldn't have any spaces or anything in it. So all one word. If you want to have like spaces, you can put underscores to signify a space there. So this is the function name. I've named it my function. Following the function declaration, we have the parentheses here. and then the colon. Then indented underneath that function definition or declaration, we have the body of the function. And in this function, all my function does is when you call it, it's simply going to print hello world to the console. And then if we wanted to instead have a function that says like hello to someone, so right now all this function will ever do is say hello world. There's nothing special about it. You call it and all it's going to do is print this line of code right here. But say we had a situation where we wanted to say hello to someone or something. Then in that case, we could define another function. So again, the def keyword space, then our function name. I'm calling this function hello. And then in the parentheses, now I'm adding a parameter name. So what's happening here is that, and then the colon, of course, and then the code indented underneath it. So basically what's happening here is the name that's passed in can then be used within the function code. And whenever somebody invokes that function, so say I said hello and I passed in world in place of name here, then this would output hello and the name there. So the format function, we haven't talked about it yet, but this is part of string formatting. It's a lot easier to do once you understand methods and things like that, because this is a string method. It's a lot easier to deal with than doing the concatenation operator like we've done in the past. But of course, we needed to understand methods before that, so hence why we first learned about the concatenation operator. But yeah, so here we have the def keyword hello as our function name. Hello accepts a parameter that we're calling name. And then within our function here, we're saying print hello. And the way the format function works is it'll replace any of these squiggly brackets within the quotes with the variable that you pass into the format method. So since I'm passing in the name variable to the format method, whatever the value of name is will be substituted for these squiggly brackets here. So yeah, here we've got the function names. In this case, it's my function. Over here, it's hello. Here we have a parameter called name. The function over here doesn't accept a parameter because there's no need for a parameter within the function body. But this one does require a parameter because we want it to say hello to someone or something. So we'd have to pass that name in here in order for that to be substituted for these squiggly brackets and then print hello to whatever the value that we pass in for name is. And yeah, so that's how this is how we would define a function. And then we're gonna go on the next slide to talk about how we would invoke a function. But before I do that, looks like we have a couple questions. So are all functions defined with the def keyword? Yes. So anytime you define a function, you have to prefix it basically with this def keyword. You'll always have def space, then your function name, and then parentheses and optionally parameters within those parentheses. So yes, absolutely correct. Great question. Def is required for creating a function. So every function you write, it's always going to have def before the function name. So does it mean our function can be named any name so long as def starts? Yes, that's absolutely correct. The function name is arbitrary. You can name it whatever you want, but keep in mind that there are some built-in function names that you don't want to use. Say, like if I tried to define a function called print, well, that's going to cause me a bunch of issues within my code, especially if I'm trying to use print anywhere else in my code. So just make sure that whatever function name you're using isn't already used by something else. If that happens, you'll typically get like a gray underline in PyCharm, and it'll say something about shadowing another function name. Just be careful of that. It's going to be pretty rare that you're going to end up creating a function that that's already named elsewhere, but just keep it in mind that it's a possibility. But yes, you're absolutely correct. You can name the function whatever you want. All right, shouldn't there be anything in the set brackets in the print area before dot format? So that's a great question. So optionally it can. There's multiple ways that you can do string formatting. And with the dot format method, you can put numbers within these brackets. That's one way that you can get, like, if you have some variable that you need to format in multiple places within your string, you could put numbers between, like, in the squiggly brackets to make sure that, like, hey, the thing at the 0 index or the 0 parameter of my format function, I want that to be substituted there. or we can just have these empty squiggly brackets, and when we do dot format, then it'll just look for the empty squiggly brackets and substitute in whatever was passed into the format method for those squiggly brackets. So it's not absolutely required to have something in the set of brackets in the print area before the format, but you can, and oftentimes it's going to be like numbers. There's another way to do string formatting where you like prefix your string with an F, and then you just put your variable name within the squiggly brackets. There's a bunch of ways to do it. I highly recommend looking into various string formatting options and finding the one that works best for you. And if anyone would like to remind me after lecture today, I can send out some resources on string formatting. Yeah, I'll try to remember, but if someone could remind me, that would be very helpful. But yeah, I hope that helps clarify that. So it's not necessarily required to put something in the squiggly brackets. You can, you just have to follow a few rules if you're going to put something in there. And this isn't the only way to do string formatting. There are a few other ways to do it. So yeah, I'll try to remember to share some resources on how to do that so that you can evaluate all your options. But great questions so far. I'm not seeing any more questions in the chat, but if anyone does have any others, please throw them in there. I think this is going very well. All right, so now for invoking a function. So functions are invoked or called using their name followed by parentheses. So on the previous slide, I had defined a function called myFunction. Now when I want to call that function, I just do my_function with the parentheses, so the name of my function followed by parentheses. And when so I'm entering this in my Python REPL environment, notice the 3 green arrows. So when I enter that there, and then I hit enter on my keyboard, this invokes that function, and all the code within the myFunction function is executed. And remember that I had defined that function to simply print hello world. So what we see here is just hello world printed to the console, because that's what my function does. It just prints hello world to the console. But if the function requires a parameter or parameters, you must pass the value or values you want assigned to the parameter or parameters in the parentheses, otherwise an error will occur. So, oops, had that one in the wrong order. So in this case, so I have my hello function. Recall that the hello function accepted a parameter name. So now what I'm passing in for the value of my parameter name is world. So now when I pass that in, the function, what it did is it took name and it formatted it into hello blank, basically. So here I have hello world, and I put my exclamation point at the end. So it says hello world is what it prints out here. Say I wanted to say hello to the class. So now I can invoke hello, and instead for my name parameter, I'll pass in class, and and then it'll print hello class out to the console there, because that's all that function really does. It takes a parameter and then says hello to whatever that parameter is. So here's this function that we had defined. So the def hello name. So with our hello function, with the name parameter, anytime I pass in world or class, what basically happens within the function is that the name, the locally scoped name variable is assigned the value that I pass into the parentheses there. So in the case up here with world, name gets the value world with an exclamation point, and then within the code, anytime the name variable or parameter is referred to, it'll take the value of whatever we passed in. So in this case, I passed in world, so it'll format in world here, and that's why we get hello world output there. And then same with class. If you pass in class in place for the name parameter, then that name parameter assumes that value. So now name has the value class, and it'll format in class to the squiggly brackets there using the string formatting. So another thing to call out is, because I gave this a parameter and I didn't give it a default value, more on that in a few slides, I need to pass in a parameter. If I don't pass in a parameter to the hello function, since it requires a parameter and doesn't have a default value, we're going to get an error. So if I try to invoke hello, similar to how I invoked my function, basically without a parameter, then I'm going to get an error here. It's saying that hello is missing one required positional argument, name. So it's trying to give you the interpreter trying to give you a little bit of a hint there that you're missing an argument. That argument is name. So you should pass in some sort of name there. Oops. So let me see if there are any questions in the chat. All right. Nope, no questions at this time. So I'm going to keep moving along. But this is just like with many other functions, basically that we've called. So with like the print function, you typically want to pass in a string to the print function, and it'll output that to the console, like we're doing right here. We put in this string here, and it'll just output that to the console. The print function doesn't require an argument. It actually has a default argument of an empty string. So if you just call print without anything passed to it, it'll just print out an empty string to the console. But we'll see more about default arguments in a bit here. But similar approach to invoking the print function as invoking the hello function here that we've defined ourselves. It's just our own custom function. Great. So parameters. So parameters or arguments. So I'm just gonna keep repeating that because you'll hear it referred to in the same way in multiple cases. So sometimes people will call them parameters. Sometimes people will call them arguments. I try to call them parameters myself. But you'll hear it both ways. So just know they're synonymous when you're saying parameters to a function or arguments to a function, same thing. So they're essentially inputs to a function that are used within the function. So order matters for positional arguments. So in this particular case, I've created a function called display exponentiation. And in this function, it accepts two parameters. It accepts a base and an exponent. So the order matters here when I invoke this function. I'll need to make sure that I pass them in correctly, and we'll see that in a moment, just after we go over this function definition. So we're displaying our exponentiation. It accepts base and exponent as its two arguments. And then within the function, we print, we have all this formatting here. And the way this is going to work is base is substituted for the first set of squiggly brackets, exponent is substituted for the second set of squiggly brackets, and then base times, which remember is our exponentiation operator, all the way back to week 2, I believe, or 1 or 2. So this is base to the power of our exponent, basically, is what this operation does here, and that'll be substituted for the third set of squiggly brackets here. So now when we invoke display exponentiation, the first argument passed, so I pass a 5 for the first argument, so that's substituted for our base variable, and then it's passed in as base, so we'll see that as the first thing before the caret, and then it's the one that's the base to the power of 2, because 2 is our exponent that's passed in. So you see how the order matters here. We get the base is 5, and then the exponent is 2. And then if we flip that around, we call display exponentiation with 2 as our first argument and 5 as our second argument, then we get 2 to the power of 5 printed to the console, and the value there is 32. Yeah, so order matters here. Just keep that in mind. You want to make sure that you're passing them in the right order for this particular case. So parameters are named, and repeated names are not allowed within your function. So we can't just have something that's like x, 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 x as our list of, say, 10 parameters or whatever. Here, this is an invalid function that I've defined, so I've called it invalid. And this accepts as its first argument x, and then I tried to add a second argument of another x, and you get an error there. See, it's underlined in red, so that PyCharm is telling you there's a problem there, and it calls out that that's a duplicate parameter name. So you need to make sure that you only pass in that with the parameters being named, they have different names, and they should be informative. X is a terrible name for a parameter. Up here, this was a better name for parameters. I have base and exponent. Because that's what I'm doing with my exponentiation function. I have a base and an exponent. So I gave them informative names, and they're not the same name. But in this case, just know you can't have two parameters with the same name. So they should always have different names. So if we can also, something else we can do, instead of invoking a function with positional arguments, you can use keyword arguments or parameter names for invoking that function. So if you really don't want to remember the order of your display exponentiation function, which that's totally fine, why would you want to memorize that if you can just use your keyword arguments? Then you can invoke your functions using keyword arguments here. So then when you're using a keyword argument, the order doesn't matter. So here I'm calling display exponentiation, and I'm being explicit that my base, the base parameter is assigned the value 10, and the exponent parameter is assigned the value 2. So then we get 10 to the second power is 100. Then here in my second call to display exponentiation, I'm doing the same thing up here. I'm assigning exponent to 2 and base to 10, but notice how the order is backwards here. The order doesn't matter when I'm using keyword arguments like this. Just know that once you start using a keyword argument, the rest of the parameters or arguments to your function need to be keyword arguments, because suddenly, order no longer matters. So it wouldn't know what I'm trying to do if I just put in a 10 here. So here I can do exponent equals 2 as the first thing in my call to it, and base equals 10 as the second one. But then we still get the same output down here. So if you want to, not memorize the order that things are in, but you can remember the name of the positional arguments or the name of the arguments, then you can use the keyword pair, basically, way of invoking that function. So then we can invoke it either of these two ways. So something I've done here just to make this extra clear is I've boxed in all of these values in red. So so up here, basically base is boxed in red. So if you look along the slides or along the slide, display exponentiation, the first argument is our base because I'm using positional arguments up here. So the first argument here is going to be the base. But then down here, because I'm using keyword arguments, I'm calling base explicitly. So I'm assigning the value 10 in both of these cases. It's just a different order, but because I'm using keyword arguments, order no longer really matters. Now, if we look at our exponent, box that one in green. We have exponent here as our second argument. Since in this case up here where I'm doing positional arguments, it's always going to be the second argument that's boxed in green. But if we look down here when I'm using a keyword argument, whatever I do for exponent equals in my keyword argument approach is what's going to be assigned the value exponent. So I hope that helps to make that extra clear on how the positional versus keyword arguments work. But if there are any questions on that, please do ask. In the meantime, I'm not seeing any more questions in the chat, so I'm just going to keep moving along. So parameters continued. Parameters can have default values. So remember I mentioned earlier, like the print function has a default value, has a default parameter of just an empty string. So in this particular case, I'm creating this another function called say hello. So instead of hello, this is a completely different function. It's called say hello because it has a different name. And here it still accepts a name parameter, but I'm giving it the default argument of world. So in this particular case, if I call say hello without an argument, without a parameter, it'll just use world, and it'll substitute in world for the squiggly brackets here because of the format method, and then you just get hello world. But if you wanted to say hello to someone else, say hello class, then you could add in class in your invocation to say hello. So if a parameter is given a default value, it becomes optional when invoking the function. So in this particular case here, I'm going to say hello, and I'm going to invoke say hello, but I'm not going to pass any argument there or parameter to say hello. So in that case, what happens is it just uses the default argument of world. So we get hello world. And but then if I wanted to say hello to someone named David, then I can call, say hello and pass in as the name parameter David. And then it'll, instead of using the default value of world, it'll use the value that I passed in, and it'll say hello David. So if you have a case where you want to have where it makes sense to have a default value, then this is how you can assign that. You would have your variable name equals and then whatever default value you want it to be, in this case world. And then when you invoke that function, the name argument becomes optional. We don't get an error saying that it's a required positional argument, but we can also still pass in our own arguments as needed throughout the code. So I can say hello to David here. So if creating a function with both required and optional or defaulted parameters, you must define required parameters first and optional parameters last. So, no parameter passed, so uses the default value, parameter passed, uses the value of a parameter. So In this particular case down here, I have a function called greet user. In that I am using a default argument. So this takes two arguments. It takes a greeting argument and a name argument. The problem here, though, is that I've assigned a default value for the greeting, but I've defined that after the required argument or before the required argument of name. That's problematic. We can't do that. We need to do our required arguments first, and then our default arguments second. Just one of those things you kind of have to memorize. Something that helps with that is, because of using positional arguments, you oftentimes when people will invoke a function, they're going to put their required arguments first, and they would want to have optional or defaulted arguments later on if they want to change the value of those. So that's why you want to have your required arguments first. So it's underlined in red because I'm doing something wrong here, and what I'm doing wrong here is that I have a required positional argument after a defaulted optional argument of greeting. So don't do that. What you should do instead is something like this, where we have our greet user function, and first is the required argument because it does not have a default value. Remember, if you don't assign it a default value, it's a required argument. If you do assign it a default value, it becomes an optional argument. So here I do name first because that's a required argument. It does not have a default value. And then I have my greeting where I'm defaulting it to hello as my second argument. And this is valid. So we don't get anything underlined in red here. And then in this case, what the function does is it just prints the greeting, comma, the name. So then we can see, like, if we passed in just world to the call to this function, then we just get hello world. But if we say world, comma, hey, then it could say hey world. So let's see some examples of that. So in this particular case, I'm calling greet user for David. So I pass in David as the string, and it just says hello David because it uses that default greeting value for the greeting. But if I want, I can change that greeting to something else. So I still have to pass David as the first argument, or because name is a required argument. So I pass David first, and then comma, and then the greeting that I now want to use in place of hello. So since I've passed the value for that greeting, it's not going to use the default value. So then it just outputs hey David. So this is how you can use a combination of required and optional arguments. Just keep in mind that order matters in this particular case. So it looks like we have a couple questions. Can you explain more on keywords? Are they words in Python? So yeah. So keywords are really things like def and all that stuff. When I say a keyword argument, that's in that particular case, that's a different context. So there are certain key or reserved words like def, and we've talked about some in the past, like continue and break. But a keyword argument means I'm just using the argument's key to pass in a value for that argument. So just going to go back to the previous slide for that. So in this particular case, I use the argument's key. The argument's key here is base, so I'm saying it's a keyword argument. You'll see that called out in a couple different places, that like something must be a keyword argument or whatever. So yeah, keywords. So that's what I mean when I say a keyword argument, is that I'm using like the key value pair basically here. So I'm using its keyword and then assigning it a value. I hope that helps to clarify that a little bit. I know that can be kind of confusing because of reserved words sometimes being referred to as keywords as well. So I hope that helps clarify it. Whenever you're talking about keyword arguments, you just call out the argument's name, which is its key, then you assign it a value. I'm just going to get this slide populated again while I move on to the next question. Do we always need to explicitly define parameters, or sometimes Python does that automatically when we write the function? So yes, if you want your function to take a parameter, it is required to explicitly define those parameters within your function signature. So this is actually called like a signature. Every function has a signature. It has a name and the arguments it accepts and whether or not they're required or optional. That's called a function signature. So you do need to define those parameters when you define your function. Python won't be able to assume what you're trying to define there. So you do need to define those. That's a great question. Make sure that you are explicit about the arguments that you want your function to accept. Awesome. So with the greeting, there's no need to use the print function, only enter the keywords. Only the enter keywords. Yes, because the greeting, so with the greeting, yeah. So in here, the function does use the print function within it. So it's the function that's running the print function for us. So I call greet user, and within the code of greet user, because when I call greet user, it just runs the code that's nested within that function. It's calling a print function in the back end using the values that I've passed. So yeah, when you're defining the function, you do need to use the print function. But when you're invoking the function, you don't need to use the print function, because if your function uses the print function, your function will call the print function. And I hope that makes sense. I know it's a little complicated and a roundabout way to think about it, but yeah, you don't need to call print in this case, because our function will actually call print. So when we call greet user, that just executes the code in here, so it calls print and it prints all this stuff out. Great question. And then this follow-up question: should specific terms be used or any? So if you're talking, and this was in reference to the previous question about keywords. So oops. So let me go back to the keyword arguments page. Whenever you create the parameters here, these parameter names are completely arbitrary. So they can be whatever you want. But once you give them a name in your function definition, and then you're calling that function using keyword arguments, you must use the same name for assigning those values as a keyword argument. So in this particular case, I've given them base and exponent as the parameter names. So then when I call them down here, I need to use base and exponent as well. I can't use like x equals and y equals or whatever, because that's not the name of the parameters as they're defined in the creation or definition of the function. So I hope that clarifies that one. Thanks for the additional clarity on that. I think that was very helpful. Yeah, please let me know if there's any other questions on that. But what really matters is how they're defined up here. So whatever name you give them when they're defined, whatever name someone else gave them when they're defined, is the name you must use when you're invoking that function using a keyword argument. So awesome questions. This is great. Please keep them coming. For now, I'm not seeing any others, so I'm going to keep moving along to the next slide. All right, so the return statement. So as mentioned earlier, all functions return data to the caller. The return keyword allows us to specify what that data should be. So functions without a return statement will always return the value none. So greet user, if we just go back to our previous slide, remember greet user, I don't have a return statement in here, but it's still going to be returning something every time that function is invoked. I'm just not assigning that value out here, so we never see what that value is. But in this particular case, if I want to assign that, I can invoke greet user and assign the value that is returned by greet user to a variable that I'm calling return value. So it's still going to execute the code of greet user. The code of greet user just prints hello and whatever argument I pass, whatever the first argument I pass is. So it's just going to say hello, David. But some value was returned by that function, and that return value is none, because I don't have a return statement within my greet user function. So since I don't have a return statement there, the value of return value is now none. So greet user returned the value none, and I know that can be really confusing. It's not that it's not returning any value; it is returning the literal value none, and the literal value none is a data type within Python. Basically, it is the nothing data type. So it is returning a value none, and I know that can get confusing, but please let me know if you have questions on it or how I might be able to clarify that further. But here I'm checking, is my return value none? So return value is none using my identity operator is, and this returns true. Return value is in fact none. So what's been assigned to return value here is the value none. But functions with a return statement return the value specified after the return keyword, which can be stored in a variable. Oh, and here, a quick note, output printed to the console via the print function does not equal the return value. So whatever is output to the console here isn't actually the return value. So return value is none in this case. Hello David is not the value returned by this function. Hello David is simply printed from the print function. If we wanted it to return hello David, we would have to have our greet user function explicitly return the string hello David, but it doesn't, it just prints it. So just keep that in mind. The output that is printed to the console via the print function within the greet user function is not the value of return value. So functions with a return statement return the value specified after the return keyword, which can be stored in a variable. So now, if we did want to have this actually return something instead of just printing it, then we can do our def get user greeting and name and greeting. So this is basically the same function as greet user, but a different name. And instead of print, we're now returning this string. So instead of printing this string, we are returning it. So now when we call get user greeting, notice how nothing is printed out into the console. So note that the return statement is not printed to the console when it's stored in a variable. Otherwise it is. So this is only something that happens in the REPL environment. So within the REPL environment here, if I call get user greeting without assigning the response of that function to another variable, it's going to output that to the console just because it needs to return it somewhere, and that's just how it works in the REPL environment. This won't happen in your code if you don't assign a return value and you have this in a actual Python file or a Python script. You're not going to see this printed to the console, but just something to call out. But over here, what I'm doing is I'm creating a variable user greeting, and I'm assigning it the value that is returned by get user greeting, where I pass in the value hello. So now when I output user greeting to the console, and remember, this is because I'm in the REPL environment, all I need to do is call my user greeting variable. I don't need to actually call print of that variable. Then we'll see that the value now assigned to user greeting is hello world. And that's because I have actually returned the string hello world in this particular case. I haven't just simply printed it to the console like I did in greet user initially. Cool. So, and this only happens if the return statement is reached. Otherwise, none is returned. So down here, if I update my get user greeting and I specify that that only these greetings are acceptable. So hello, hey, hi, good morning, good afternoon, good evening. And basically what I'm checking here is if greeting is in that list. So remember our in operator for checking if something is present in a collection of variables, in this particular case, a list. So only if the greeting is within this list will it actually return that value there. If I were to give something that isn't in this list, then it's going to return none in that particular case. So now now that I've updated get user greeting, if I do get user greeting goodbye, and so get user greeting, and I put David as the name, and then my greeting is goodbye. Well, that's not really a greeting. That's a saying goodbye to someone. So we have now if I output that there, nothing is output to the console. Like up here where I had get user greeting world, we saw hello world output to the console. That's because nothing was returned. None was returned from get user greeting. So then down here where I'm taking the user greeting variable and assigning it the value that's returned by get user greeting, where I pass in David and goodbye, user greeting is none. So the reason for this, just to go through the logic of the code, is that because I passed in goodbye for greeting, first we're going to check if goodbye is in this list. Goodbye is not in this list, so we never reach our return statement. So nothing is returned from the function. But if I were to just invoke the function without goodbye, or if I used any one of these greetings in this list, then user greeting would be assigned a value like it was up here. So just keep in mind that the return statement must be reached in order for whatever it's returning to actually be returned. So it's, if that line of code isn't reached within your function, then it'll just return none, like as if there weren't a return statement in that function. All right. So return value equates to the input. So not always. That's an excellent question. So in this case, I'm using variables or my parameters that I'm passing in. They're all being output to the console because I want to show the flow of a variable being used within that function. But it's not always going to be what you pass in as the input. It really depends on the logic that is executing within your function. So, say you just had something where, you had a function called like exponentiation. And all that it does is it takes two values and the first value, it takes the first value to the second value. So instead of, our display exponentiation, it's just exponentiation. So it'll just do that calculation for you and return that value. Then, say we had 5 and 2 passed into our exponentiation function, then it's going to return 25 if we return the exponentiation of those two values. So it's not necessarily what's in the input. That's just in the examples that I'm using here. Whatever you enter after your return statement here is what will be returned by the function. It doesn't have to be what was passed in as the parameters, but the parameters should have some sort of bearing on what that return value is going to look like. I hope that helps clarify that. Excellent question. Yeah, the questions are great today. Please keep them coming. But I'm not seeing any others, so I'm going to move along. So the return statement continued. You can return multiple values with a single return by separating the return values with a comma. So in this particular case, I'm creating a function called get integer quotient and remainder. So I have a dividend and a divisor. The dividend is basically what's being divided, and the divisor is what it's being divided by. Just in case you're not familiar with those math terms. So in this particular case, it takes two parameters, dividend and divisor, and it's going to return two values here. So it's going to return the dividend floor division. Remember, the double slash is our floor division all the way back in, I think, week 2. So we have dividend floor divide by our divisor, and then we have the dividend modulus our divisor. And remember, the modulus function is used to identify like the remainder of a division operation. Again, refer back to week 2 if you need a refresher on operators. So I'm returning two values here. They are separated by a comma. So the first one I'm returned is the floor division result of these two variables. And then the second one is the modulus result of these two variables, which it will give me the remainder. So this is returned in the form of a tuple. So if I call get integer quotient and remainder using the variables 10 and 3. So in this particular case, 10 floor divide by 3 is going to be 3. Because it would be 3.333 repeating, but because I'm floor dividing, we just get 3. So that's the first value that's returned. And the second value that's returned is going to be the dividend modulus the divisor. So since 3 goes into 10 evenly 3 times, and then that value is 9. The remaining value that it doesn't evenly go into is 1. So we get our 1 remainder there. And again, I don't want to dive too much into the operators here. If you have questions on operators, please revisit lecture 2 and the materials for lecture 2. And if you have any particular questions on those, please send me an email or comment on that YouTube video from week 2. I just don't want to spend time going over operators again here, but I know the modulus operator is something that people always have a lot of questions on. So just trying to get out ahead of that one. So notice how here it's returned in the form of a tuple. So remember, tuples have parentheses and then our first value and our second value. They're immutable, all that good stuff. So this is a tuple here, and the values in that tuple are 3 and 1. The first value in the tuple corresponds to what was entered before the comma. The second value of the tuple is what was entered after the comma. And if we had a third one here, there would be a third value in the tuple, and it would correspond to whatever came after the second comma, etc. So just keep that in mind. Whenever you invoke a function that returns multiple values, it'll return those in the form of a tuple. But something else that's really useful to know is we can unpack that return by assigning it to multiple variables. So now we are calling get integer quotient and remainder, passing in 10 and 3. and I'm assigning it to two different variables. I'm assigning it to my quotient, comma, my remainder. So now basically what happens is the first value of the tuple is unpacked into our quotient variable, and the second value of our tuple is unpacked into the remainder variable. So you can kind of think of these as corresponding, like, this quotient is the same thing as dividend floor divide divisor, and then this remainder is the same thing as dividend modulus divisor. So the order matters here again. Remember, tuples are ordered, so make sure that you're specifying the order correctly. But now, when I output the value of quotient to the console, it's just going to be 3. It's not a tuple because it just grabbed the value basically at index 0 of our tuple. And then the remainder, outputting that to the console, that gets whatever was at index 1 of the tuple because of the way we unpacked it here. So unpacking tuples is very valuable. It's something we've actually already done. So think back to the last lecture where we did the os.walk command. So with os.walk, that returns a tuple of values, and it returns the tuple of like a root folder or the root folder that you're on, the folders within that, the subfolders within that folder, and then any files within that folder. So that's remember that when we did like for root, subfolder, and file, that was unpacking a tuple because os.walk returns a tuple of first one being the current root path, second one being the subfolders, and the third one being the files in that directory. So we've already done unpacking in the past, we just didn't know it. And this is just being more explicit about how you would unpack those variables here. Okay, so when unpacking, the programmer will request the quotient, then the remainder. So great question. It depends. In this particular case, yes. So in this particular case, because what's returned by this function is first the quotient, then the remainder, then yes, we want to first get the quotient when we're unpacking. So the first value should be our quotient. Again, this variable name is completely arbitrary. I just like to use very informative variable names. And then the second one is our remainder. So I'm giving it an informative variable name. So that'll be assigned the value of the remainder there, but that's only because that's how my function is written. If I wrote my function to return the remainder first and then the quotient second, then I would need to have remainder comma quotient. So it really depends on how the function is defined, because whatever order that I define it in up here in my return value is how it's going to be returned in my tuple here, and then is how we would unpack it down here. So in this particular case, for this exact function, you're absolutely correct. The programmer would request the quotient, then the remainder. But if I had written the function differently and I had the remainder before the comma and then the quotient after the comma, then it would be flipped. We would have remainder comma quotient here. I hope that helps to clarify that one there. Excellent question. Cool. If there are any follow-ups, please add them to the chat. Otherwise, I'm going to keep moving along. But seriously, awesome questions today. I'm loving them. Keep them coming. All right. So documentation strings. Or doc strings for short. These are extremely valuable. You can tell people how to use your function using a doc string. So documentation strings, or doc strings for short, are essentially comments used to document a function's usage. Typically, they are wrapped in triple quotes, as we have down here. So I have my triple quotes and then my doc string right here, and then ending and then closing the triple quotes there. Remember that triple quotes can span multiple lines, so that's why they're so valuable. And they actually should be, in order for Python to recognize it explicitly as a doc string, it should be wrapped in triple quotes like this. So a doc string typically contains 1 to 4 parts. At an absolute minimum, every doc string should contain a description of your function. You should always call out what it does here. So in this particular doc string, I have my get user greeting function that we had previously, and I'm giving it the definition, or I'm describing the function, and I'm saying it's a function to build a greeting to a user using, and I don't know why I had the using here, but function to build a greeting to a user, basically. So this is the description of my function. Now, optionally, if applicable, we should include explanations of our parameters. So here, and this is just how I like to write my doc strings. The formatting of doc strings is completely up to you. This is how I like to do mine. I think it's really readable. You have your description first, your argument second, your return values third, and then any errors that might be raised by the function fourth. But I just don't have this function doesn't raise any errors, and we haven't talked about that. So we'll get to that later on. But yeah, so parameters would be second. So I like to say args, and then tabbed underneath that, you have param name. And this part you should do with the colon param and then the name of your parameter. So here I'm defining the name parameter up here. So I have colon param name, and then I'm describing it. It's a string representation of a user's name, i.e. the user to greet. And then my second parameter is greeting. And I'm saying that that's a string greeting to use when greeting the user. This defaults to hello. So something to note here is if you have a default value, you should call out what that default value is going to be. Another thing that you should always call out when you're talking about parameters is the data type that you want that parameter to be. So I'm saying it's a string representation, a string greeting. So call out the data type and call out if there are any defaults when you're talking about what your parameters are. So data type, what it means logically, and any default values is what you should include in your doc string for parameters if they apply. So if this function didn't have any parameters, then I would just skip this args section, and then return. So I have a return section here. Again, the colon return colon. This is something you should have in yours, and it's a greeting in the format greeting comma name exclamation point. If a valid greeting is entered, else none. So here you want to specify all the possible return values. So in this particular case, this will return the string greeting name in the case that they entered a valid greeting. Otherwise, it'll return none, as we saw previously. So it's good to call out what's being returned. It's returning a greeting in this particular format. If a valid greeting is entered, otherwise it's going to return none. And I'm just kind of doing shorthand programming logic here with if a valid greeting is entered, else none. So hopefully that makes sense. So yeah, that's a doc string, extremely valuable because then people can understand how to use your function. People who aren't you, because of course you'll know how to use your function, right? You wrote it, but you might also have to come back months later after writing that function and try to remember how to use that function. Instead of having to read through the code of the function, it helps to just read a very human readable understanding of that function. So all of this up here is the doc string. First I have my description, then I have my parameters, then I have my return value. And if this raised any errors, I would have it down at the bottom. This is how I like to create my doc strings. Create them however you feel comfortable, but always include these things as they are applicable. So minimally, it needs a description. If it accepts parameters, include a parameters section. If it returns a value, include a return section. If it doesn't return a value, everybody knows from their experience with Python that that's going to return none. So then you can just leave that section out. People know that if there's no return section in your doc string, then they're going to assume that it returns none. And if it were to raise any errors or exceptions, then you'd have a raises section. But we haven't talked about errors or exceptions yet, so I'm not going to put that in here. Oh, looks like we've got a question. Great. With a doc string, definition should be stated, parameter and return value, then head to the conditional. Yes, absolutely. Great question. It should always be the first thing in your function definition. It should always be right below the function definition. This is a convention that then your function will actually, or Python will actually recognize that that is the doc string of your function. And then there's a way that people can retrieve that doc string of that function in order to read about your function. And we're going to talk about that on the next slide. But yes, absolutely. First thing when you define a function should be your doc string. Then you have the code of your function. Excellent question. Otherwise, it's going to be interpreted as a comment, not as a doc string. So yeah, great question. Yes, you're completely right. It should be your doc string first, then the code of your function. Awesome. Thank you for that question. That is a great one to call out. All right, so again, just to repeat, formatting is flexible. This is just how I write my doc strings. Come up with something that makes sense to you, includes all the key components, and be consistent. So I always write my doc strings like this. I have my definition, my parameters, my return, and then a raises section if it raises any exceptions. I always just be consistent with how I'm writing the function with writing my doc string here. Yeah, you just don't want them to be different from function to function. And yours don't have to follow my pattern here. People think it's redundant to have args and then the colon param name and colon param greeting colon. I get it. You know, that does seem repetitive because param indicates that it is a parameter. I just like to have it like this because I think it's even more readable to separate everything out like this. So yeah, just wanted to call out, you don't need to format them just like mine. Just make sure you include the key parts whenever you're creating those doc strings. Awesome. All right, so doc strings continued. So functions all have a special attribute, and this is a double underscore. So underscore underscore doc underscore underscore with the value of the doc string that you entered when defining the function. Use this attribute to learn about new functions. So here I have print get user greeting dot, and I'm using the dot notation to retrieve this attribute of that function. And this is underscore underscore. So 2 underscores here. I know it looks like one long underscore. There are 2 underscores there. Underscore underscore doc underscore underscore. And then when I call that print function, what outputs is that that doc string that I had put on the previous slide. So now anybody who they see my function, they see it's called get user greeting, they have no clue how to use it necessarily. So they can use get user greeting dot double underscore doc double underscore, and that will print out the doc string of my function. And then they can read through this. It's a function to build a greeting to a user. The arguments, there are 2 arguments, name and greeting. A string representation of a user's name, and then the string greeting. Something else to note that I forgot to mention in your args, do keep them in the order that they are in your function definition. So if I go back to my previous slide, in my function definition, name comes first, then greeting. So I have name as the first line here, then greeting as the second line in my argument section. So make sure they are properly ordered, because remember, positional arguments matter in this particular case. Yeah, so then anyone can read about my function using this get user greeting dot double underscore doc double underscore. This is a excellent way to learn about new code. So whenever you're trying to learn about new functions or a new package, we'll talk about packages in a future lecture, and you're not sure how to use a function, don't hesitate to do the dot double underscore doc double underscore and then read the doc string that whoever created that function entered. Ideally, all of them will have a doc string. Unfortunately, that's not always going to be the case, but it's definitely something that you can use as a resource. It helps a lot. I do it all the time to try to understand about functions. All right, it looks like Akeem, you have your hand up. Did you have a question? Where should we put the triple quotes? It's a great question. Oops, wrong direction. So in this particular case, first, I like to have my triple quotes on the line before I actually start my doc string, and then the triple quotes at the end. I find it just a little more readable. So it's totally up to you, really. The triple quotes just need to start your doc string. So I could have put, my triple quotes and then immediately started the definition of the function up here. Just make sure that they wrap your doc string. So start it with triple quotes, end it with triple quotes. And that's the only rule, really, to start with triple quotes and end with triple quotes. But just make sure that whole doc string is at the very beginning of the function definition. Yeah. Awesome. On to the next slide, since I don't see any other questions. All right, scope. The scope of a variable or function defines the context in which that variable or function is recognized. Variables we've defined and used in class so far have had a global scope, meaning they can be referenced from anywhere within your code. But if a variable or function is defined within a function, you can define functions within other functions, believe it or not. So if a variable or function is defined within a function, it is part of the local scope of that function and cannot be accessed outside of that scope, i.e. outside of that function. So let's see some examples. Up here, I have x equals 10. And then I have print x. I have my function where I'm defining my function, and I'm printing x within my function, and then I invoke my function here. So here, x, its scope, because it's at the top of the file, it's not indented underneath anything. The scope of the variable x is a global scope. So this variable x is accessible outside or anywhere in my code. So I can print it outside of a function, or I can also print it inside of a function. So in this particular case, when I run this code, since I assign x up here and I print x, then I get 10. And then I called my function down here. So calling my function down here, called print x again. So I get 2 10s outputted to the console here. So 10 has a global scope. It's global to the file. So it's accessible anywhere within the code of that file. But now, if I create a function and I call it my function, and within that function, I define a variable called locally scoped variable, and I assign it the value I am not accessible outside of my func. And then I print that here. If I call my func, that's fine. It'll work. It'll print my locally scoped variable. But because I defined this variable within the myfunc function, this variable is only accessible within this function. You cannot access it outside of that function. So now if I try to print locally scoped variable outside of my func, it does not work, because that variable, its scope is only within the myfunc. So any reference to my locally scoped variable would have to be tabbed underneath the myfunc function here. You cannot use it outside of that function. So, and that's where you get the unresolved reference, because I haven't defined it at the global scope. I've only defined it at the local scope within my function, the local scope of my function here. So scope continued, you can have multiple variables with the same name, one in the global scope and others inside the scope of functions. This is called shadowing. So here I have x equals 10, and then within my function, I'm taking x and assigning it the value 20, and then I'm printing that value x. And then here I'm going to call my function. So what this is going to do is it's going to call my function. It's going to create a locally scoped variable x, assign it the value 20, and print that x here. Up here, I have a globally scoped variable x that I've assigned the value 10. So when I call my function, first it's going to create this locally scoped x variable and print that. So we'll see a 20 output. And then we're going to print x at the global scope, and that x at the global scope is going to be 10. So when we call my func here, we get 20 because of the locally scoped value of x. But then when we call x outside of that function, now we get the global scope value of that function. So here, you're going to see this underlined in gray. The reason is because what I'm doing here is I'm shadowing the value of x. So x has a global scope, but I'm shadowing its value within my function, giving it a locally scoped value. This does not have a bearing in this particular code. This does not have a bearing on the globally scoped variable. And the reason it's underlining it in gray is because this is confusing. So ideally you shouldn't do this, but I just want you to know it is possible. So you can shadow variables here. PyCharm is giving me a warning here because this is bad practice. So try to avoid doing it, but just know that it's a possibility. Yeah, and if when I hovered my mouse over that, it says shadows name x from outer scope. So it's recognizing that there is another variable x in your outer scope that this locally scoped variable of x is shadowing. So this is called shadowing. But if you want to get a reference to a globally scoped variable from within a locally scoped variable, you can use the global keyword. Now in this code, the only change I've made, it's the same code as up here, but now I've called global x first. What that means is that I want to use my global variable x within this function. So now what happens when I call my func here is that it's going to call, my func, it's going to get the reference to my global x variable. Now, when I take x equals 20, I am actually reassigning the global value of x to 20, and then I'm printing that out. And I'm going to print x here just to show that what I did within here, because of my global x and then reassignment of x within the function there, x at the global level has also been impacted by this reassignment. So now we get 20 and 20. So the call to myfunc outputted 20 because of this print statement here. And then the call to print x down here, that also outputted 20 because this reassignment that occurred here, because I did the global x, the reassignment applied to the globally scoped value of x. Cool. So hopefully, if you have any questions, please throw them in the chat. I know this scoping can get very confusing. Just know that if you ever need to reference a globally scoped variable within your code, especially if you're doing a reassignment, use the global keyword to do that. Great. And otherwise, if you don't want to be using the globally scoped value, use a different variable name. That's the best practice. Don't do this shadowing here. It'll get confusing. I guarantee you'll get confused. Your coworkers will get confused. Anyone reading your code will be confused. Just try to avoid it. Cool. All right, so I see a question just came in the chat. So if x equals 10, how come the global x is equal to 20? So the reason here is actually, so we assign it the value 10 up here. At the global level, initially, it is assigned the value 10. But as soon as we call my function, first we get a global reference to x. So we want any reference to x within my function to be that global x value up here. So now we're referencing our global x variable. So anything that we do with x within this function is now in reference to or will directly impact the global x variable. So now I've reassigned it the value 20. So I took x, reassigned it the value 20, and then I printed that out here. So now I've actually reassigned the global value of 20. Up here, because I didn't do global x, I didn't reassign the global value of x. I simply assigned a local value of x. So yeah, this is one of those things that you really just need to practice. It's hard to understand and wrap your head around just from talking about it. Please just use this code. Something that I would recommend is throwing a print statement up here, like print x before calling, or throw a print statement here, print x before calling my function, and then you call my function, and then you print x again after, and then you'll see the impact. Try it with and without global x. Yeah, highly recommend just trying this on your own. That's the best way to really get a good understanding of it. All right, another question. Are there specific cases when shadowing can be recommended? Not really. Shadowing is considered poor programming practice. But excellent question. There's a reason PyCharm is underlining it here. It's because it's confusing. It's bad practice. You should avoid it wherever possible. The only reason I can really think that someone would have shadowing in their code is because of, I guess, being lazy and not wanting to come up with another variable name. Yeah, it's one of those cases where someone just doesn't want to come up with another variable name, because all I could have done here in order to avoid shadowing is use the variable y, or even if they have to have the same name because of some arbitrary reason where it makes the most sense for the meaning of that variable, then something you could do is like give that variable name _local or local scope or something like that. Yeah, so really just avoid shadowing. Shadowing is just a bad practice, but excellent question. It's not recommended at any time. I just wanted to call out what would happen in these particular cases, because this will throw you off. I guarantee it. Great. Another question at the bottom, that you cast my func. Are we writing it literally like that? Why are we calling? Okay. At the bottom, you cast my func. Are we writing it literally like that? So I'm not sure I'm following the question there. So here, the reason I'm calling it like this is because this is my invocation of that function. So remember, to define a function, we have def and the function name, parentheses with parameters needed after it. And then down here, I'm invoking that function. So I am actually calling it. So I don't need the def keyword or anything, and I just have my func with the parentheses after it. I'm hoping that's what you're asking here. If not, please, if you could add some additional clarity into the chat, that would help a lot. But in the interest of time, I know we're going way over, so I'm going to keep moving along. Resources here, again, can't recommend enough. Use them. I hope you all have been using them every single week. These resources are extremely helpful, freely available on the internet. Can't recommend them enough. Okay, so since we are already well over, let's go over the assignment for this week. And there's a typo here. So for each of the below questions, write a function to solve the use case at hand and provide a few examples of using the function. The questions will get increasingly challenging, both technically and in terms of being less descriptive as to exactly what is required to accomplish the task as you progress through the assignment. Make sure to document all of your functions thoroughly with docstrings. So question 1 here, write a function that accepts 2 arguments, a numeric value as well as a list of numeric values. This function will be used to multiply each value in the list by the number passed and return the resulting list after this multiplication has been applied. For example, if I gave the inputs 2 and the list 1, 2, 3, 4, 5, the return value would be 2, 4, 6, 8, 10. Now for 2, write a function that converts a temperature entered in Fahrenheit to Celsius. Number 3, create a function that accepts 3 arguments corresponding to the current temperature in degrees Fahrenheit or Celsius, and an indicator telling if the temp in degrees is Fahrenheit or Celsius, and the current weather. It must be one of cloudy, raining, or sunny, and prints out what the caller should wear based on these values according to the following. So first, if the temperature is in Fahrenheit, use the function created for question 2 to convert it to Celsius. If the temperature is below freezing, output it's probably best to stay inside. Otherwise, output it's warm enough to go outside. And in the case the weather is sunny out, yada yada, conditionals here, and it talks and it's kind of calling out all of the various like Boolean expressions you would need here. With the in the case, you can think of that as if the weather is. So I hope that would make sense. Please let me know if there are any follow-up questions on that. For 4, create a factorial function. So a factorial, denoted by an integer followed by an exclamation point, is the product of an integer and all the integers below it. So for example, the factorial of 4 exclamation point, is equal to 4 times 3 times 2 times 1, which equals 24. Note that 0 factorial always equals 1. Write a function that calculates and returns the factorial of a number. Do not use the existing function. Use an existing function for this. Come up with the logic yourself. So that's just calling out there is a function out there that'll do factorial for you. I want you to write this function yourself. And what I'm actually going to do is I am going to make 4 and 5. I'm going to make these extra credit. So all you need to do are 1, 2, and 3 for the assignment here. I know this is getting to be a lot. These 4 and 5 are extra credit. You'll get an extra quarter of an assignment worth of credit for completing both 4 and 5 correctly. Just like how we had in I think it was week 2, you got some extra credit for doing the second paragraph. We're going to do that same thing here. So this is a great way to make up partial credit for missed assignments or anything like that, or missed classes. So highly recommend to do it. But if you don't have time, it's not going to impact your grade. Just to get a passing grade, get 1, 2, and 3 right. Okay, so that's for 4. And then 5, write a function that can convert between US customary units and metric units. Here's a link to various conversion tables. Include the ability to convert at least the following feet/inches and meters, and vice versa, miles and kilometers, and vice versa, fluid ounces and milliliters, and vice versa, gallons and liters, and vice versa. So again, 4 and 5 are extra credit. I'm just going to call this out with a highlight. So you'll get an extra quarter of an assignment worth of credit if you successfully complete 4 and 5, but to get a full passing grade for the assignment, you only need to complete questions 1 through 3. Great, so I think that is all for this week. Sorry for going about 20 minutes over. We had a lot to cover this week. I know there's a ton of information in that slide. Please take some time to go over it again, and even watch the videos on YouTube once I upload it to YouTube. I'll be sending that out along with the slides and the assignment here shortly. But yeah, I think that's all for today. So thank you all so much for joining. I hope you have a great rest of your weekend. One thing I do need to mention is next weekend I will be out of town. I'm going backpacking, so I won't have a phone or anything. I will be completely unreachable next weekend. So I'm going to talk to Vraj and Gaurav and see if one of them are willing to do the lecture next week. Otherwise, I'll just send out a link to the lecture from last year, and you can all use that in place of lecture next week. But I'll talk to Vraj and Gaurav, see how we want to proceed, and then I will keep you all informed. But I hope you all have a great rest of your weekend and an awesome upcoming week. And I won't see you next weekend, but I will see you the weekend after. And I will take some time. Again, sorry about not grading all the assignments for this week. It's been a very busy week, so I will keep you posted. Yeah, I'm liking the comment, Patricia. We'll see if we can get Gaurav to do it. But anyway, yeah, hope you all have a great rest of your week. I will talk to you over email and in 2 weeks. Thanks.